Alright, we've got something very exciting today. It's the DYS F1104 tiny combo set from gearbest.com. Basically, it's a complete powertrain for a brushless microquad in a box. It comes with 4 B1104 4000 kV motors, 4 XM10A ESCs, 6 3020 props, and some assorted mounting hardware. Everything comes in this nice sturdy plastic case, so we pop it open. So it's all packed into these foam trays. We've got in the top one 3 ESCs, 2 motors and 3 props. And the bottom one, our last ESC, 2 motors, 3 props and the mounting hardware. These motors are tiny. If you look at it next to my thumbnail, I mean, it sort of gives you an idea. Here it is next to an XT60 connector. It's ridiculous how small these things are. To really ram that point home, here it is next to a 22 size motor with a 5-inch prop. It's just, it's ridiculous. For mounting, we have 4 M2 threaded holes, 4.5mm out from the center of the motor, so 9mm between centers, all symmetrical. And you have 3.5mm from the very base of the motor to the stator wiring. So your mounting screws shouldn't penetrate more than about 3mm into the motor, otherwise you risk fouling on the stator wires. Let's have a look at some figures. 14mm into total diameter. The body is about 12.5 high, 13.3 with the end of the motor shaft, and just the body to the top of the motor shaft is about 16.7. The prop shaft is 1.5mm in diameter. Now, the prop mount is actually pretty interesting. Unlike bigger motors where you'll have just a single threaded shaft that a nut threads onto to hold the prop on, or smaller motors where it's just a press fit, this actually uses a smooth shaft to locate the prop, and then 2 holes either side that you put screws into to hold the prop in place and take the torque, which is pretty cool. The motor wires are about 105mm long, with the last 20mm stripped, and they look to be about 0.2mm in diameter, so I think that corresponds to about 32 gauge. It looks like they're about 5.5 grams with full length cables. Obviously if you shorten them you'll lose a little bit of weight. The motor shaft is secured to the base with an E-clip. I'll just try and pop that off now. With the E-clip removed, we can disassemble the motor, and we'll have a look at the rotor first. All of the magnets are nice and evenly spaced. It doesn't look like their pockets are machined into the rotor itself, but there's a decent amount of glue in between them and holding them to the rotor, so they shouldn't really move around. I don't see a grub screw or anything else to secure the motor shaft, so my guess is it's just pressed into the rotor, which is fine. Moving over to the stator now, we'll just have a look. The bearings look to be about 4mm in diameter. Yeah, top and bottom. Obviously with 1.5mm internal diameter. And the windings look pretty clean, so all in all not bad. Let's have a look at a speed controller now. These are the XM10A units that ship with the kit. They're specifically designed for high-speed motors like the 4000 kV units that we're using here. Interestingly, the DYS site states that they're only to be used with 2 to 3 cell lipos, but the sticker actually states 1 to 3 cells. So I'll test them on 1 cell, but I suspect the thrust isn't going to be worth it anyway, even if they do run. As you can see, there's no 5-volt power wire coming out of them, so it's an opto ESC. Obviously, you'll need a separate BEC. They come with a BL Heli bootloader and firmware, so if you've got a flight controller that supports pass-through and a firmware that supports pass-through, you can program them through your flight controller, which is pretty neat. Refresh rates up to the maximums of what they'll do, so standard servo mode up to 500 Hz, that's the theoretical maximum, so you can't get any quicker than that, and up to 3 kHz in one-shot 125 mode. We'll have a look, sizes. Looks like 12.7, this is with the heat shrink on, 12.7 wide. Full size of the heat shrink is about 31.3 millimeters long, and looking about 4.6 millimeters high. I've actually got one that I've removed the case from just so you can get the PCB size as well. And it is 12 millimeters wide by, looks like about 23 millimeters long, and at its highest looks like 3.89 millimeters, so actually pretty small once you get rid of the heat shrink. There's a significant weight difference too. I've also stripped off, it comes with a standard servo connector, but I don't think many people are going to use that. So I think from the factory they come in at about 5 grams. No, 4, no. Get that on the scale. No, 4 grams exactly. And then we'll have a look. Stripped down, so I've removed the motor wires, because most people are just going to strip them off and then cut down the motor wires and solder them directly to the ESC rather than using the ESC's motor wires. I've also taken off the servo plug and the heat shrink. You get it down to 2.5. So significant weight savings to be made. With the heat shrink, you're up to 3, so you can still save a gram per corner if you just strip off the servo plug and the motor wires. The kit comes with 6 props to get you started. They're all the same size and pitch, all 30-20, so if you're flying line of sight, you can put different coloured props on the front and the back of the aircraft to help you maintain orientation. For mounting hardware, there are 4 packs of M2 screws. In each pack there are 6 M2 by 4mm countersunk head screws and 6 M2 by 6mm socket head screws. The countersunk screws should be driven with a number 1 Phillips bit, and the socket head screw should be driven with a 1.5mm hex bit. You can use either type of screw to mount the motor to the frame, but only the socket head screws are long enough to mount the prop to the motor. As expected, the one-cell results are not great. The ESCs do actually run all the way down to about 3.5 volts, but they start having trouble starting the motors, and below that they get a little bit flaky. My guess is that they're running a low dropout 3.3 volt regulator, and so somewhere in the 3.4 to 3.5 volt range it reaches its dropout voltage and resets, so not great. But even at 4 volts, the max thrust was only 23 grams, so you can get more out of an 8.5mm brushed motor. The extra weight penalty of the brushless setup just isn't worth it down at these low speeds, and perhaps with a much more aggressive prop or a larger prop you might get a little bit more out of them, but I don't think one cell's really that usable on this setup. You might as well go with 2. 2 cells are about the minimum you're going to want to run with this setup. They run nice and cool, even in a pusher prop setup sitting on the bench. The motors were nice and cool, and the thrust has more than tripled to 77 grams at 8 volts, pulling 2.3 amps, which is super impressive. The combined weight of the motors and stripped down speed controllers is 34 grams, so if you're going for a 2-to-1 thrust to weight ratio, which is probably the minimum, you can spend 120 grams on the rest of the quad. So that's not including motors and speed controllers, so you've got a bit to play with. And if you want 3-to-1, you only got 68 grams, which could be a little tough. I mean, your battery's probably going to be 20 grams of that. So unless you're doing some really lightweight frame, you might struggle. Anything more than about 2.5-to-1, and you're probably going to want to go to 3 cells. 3 cells are where things start to get really interesting. They did run a little hot on the test bench in the pusher configuration, but my guess is in the air, and especially in a puller configuration, when you've got airflow running across them, it should be fine. They'll run a lot cooler. We saw double the thrust from last time, so 147 grams at 12 volts, and at sort of 4.1 and above you'll see even more than that, so we're talking over 600 grams of thrust from a little micro quad, which is incredible. I've put this chart together to give you an idea of what the thrust to weight ratio would be with a given configuration on 3 cells. It already takes into account the weight of the speed controllers and motors, so you just need to add the rest of the components up. So for an example, if the rest of your aircraft, not including the speed controllers and motors, weighs 150 grams, the thrust-to-weight ratio will be 3.25 to 1. In conclusion, these run really well on either 2 or 3 cell voltages. 2 cells probably ideal if you're looking to build a lighter quad or you're particularly concerned about motor longevity, but as I said before, I don't think the 3S heat issue is going to be a problem in the real world. Also, if you're looking to run much more aggressive props than what are included in the box, you might want to stick to 2 cells. Most people, myself included, will be running the standard props on 3 cells. They put out a ton of thrust and don't draw too much current, so it's definitely a winner in my book. The pack's a great way to get started in brushless micro quads, whether you're starting out or upgrading. Like I said, it's a powertrain in a box. It makes things really easy. Everything seems to be well built, and you can save a little bit of money if you buy it all together versus buying individually. I think the pack right now is just over $80 US, including free shipping. So that's pretty good. I'm really excited to get these into a quad. Just got to get some other parts together and get in the sky. The purchase link will be in the description. Thanks very much for watching.